You ever wonder what the real secret ingredient is behind all this powerful AI we keep hearing about? Well, I'll tell you, it's not always about having the biggest computers or the most complicated algorithms. Today, we're going to pull back the curtain on the one process that truly turns messy, raw data into predictive gold.
Okay, let's dive right into it. We tend to think of machine learning models as these brilliant superbrains that can just, look at a pile of data and magically find all the patterns. But here's the thing. They actually have a huge problem with data in its raw original form.
I mean, think about a simple piece of data, like a date or a city name. For you and me, that's packed with meaning, right? We know that date is in the fall. We know that city is a major travel hub. But to a machine learning model, it's just a random string of text or numbers. It has no built-in context. It can't just know the weekendness of a Saturday or the economic vibe of a particular city. So, there's this absolutely crucial translation step that has to happen. See, on the left, you've got the raw facts, just as we collect them. But on the right, that's what a model actually needs to see: structured, meaningful information. We have to build a bridge from the data we have to the smart data a model can actually use. And that bridge, that kind of magical transformation process, has a name: feature engineering. This right here is where the real art and science of data science collide. And frankly, it's what separates a pretty good model from a truly great one. So what is it, formally? Well, it's the whole process of taking that raw, clunky data and just reshaping it, molding it into these perfect little features that are specifically designed to help a model learn better, learn faster, and be way more accurate. It's really about learning to speak the model's language. And listen, this isn't just one single thing you do. It's this whole creative process. It can mean inventing totally new variables out of thin air, or maybe just tweaking the ones you've already got. It means digging deep to pull out hidden info, like that whole weekend idea from a date, and then, this is really important, picking out only the most useful, most powerful features to keep. This quote pretty much says it all. You can have the fanciest, most expensive algorithm in the world, but if you feed it junk data, you're going to get junk results. It's that simple. The features you create, they're the foundation for everything that comes next. So, how do people actually do this? What are the tools in the toolbox that data scientists use to sculpt data into something a model can understand? Let's take a look at a few of the most powerful techniques. All right, first up, let's talk numbers. Because sometimes a very specific raw number, like a person's exact age, isn't nearly as helpful as the general group that number belongs to. A really common way to handle this is a technique called binning. So instead of telling the model a person is exactly 37, we just tell it they're in the 36 to 60 age group. Now, why would we do that? Well, it helps the model find much broader patterns that apply to whole groups of people, instead of getting lost in the noise of every single individual age. Okay, but what about data that isn't a simple number? This is where feature engineering gets really creative. We're talking about unlocking the hidden treasure inside things like dates and plain old text. You know, a single timestamp can be an absolute goldmine of information. From just one date, we can pull out the year, the month, the season, whether it was a weekday or a weekend, even if it was a public holiday. Just think about it. If you're trying to predict retail sales, knowing a day is a Saturday in December is way more powerful than just having the raw date. And what about text? Well, models don't read sentences like we do. They process numbers. So a classic technique to bridge that gap is called bag of words. It basically just breaks a sentence down into its unique words and then counts how many times each one shows up. It sounds simple, I know, but it's a surprisingly effective way to turn language into numbers a model can actually work with. All right, theory is great, but let's see this stuff in action. I want to show you the dramatic impact this can have in a real-world scenario. Let's imagine we're building a model to predict house prices. This is where feature engineering stops being an abstract idea and starts creating some real value. So we start with our basic, raw ingredients. We've got the square footage of the house, the number of rooms, the location, and how old the house is. This is our before picture. It's fine, but it's missing so much important context. Now the feature engineering chef gets to work. We can combine area and price to create a whole new feature, price per square foot. We can calculate the distance to the city center from the raw location data. We can even bring in our own outside knowledge, like the local school rating. You see, these new features are just so much more insightful than what we started with. And
Here is the payoff. Just look at that jump. Before we did any feature engineering, our model was kind of stuck at 65% accuracy, not something you'd want to rely on. But after we fed it those smart new engineered features, the accuracy skyrockets to 92%. This is the big takeaway, folks. This isn't just a small improvement, it's a total game changer. It's the difference between a model that barely works and one that's genuinely powerful.
So as we start to wrap this up, it becomes really clear that feature engineering isn't just some mechanical push-a-button process. It's really this beautiful blend of technical skill, deep knowledge about the subject, and, a healthy dose of creativity. So, what are the big things to remember here? First, creating new features is almost always the biggest driver of a model's performance. Second, your own real-world knowledge about a topic is probably your most powerful tool. Third, never forget that things like dates and text are full of hidden patterns just waiting for you to find them. And finally, sometimes the smartest move is to simplify things by picking just a few really powerful features. I love this quote because it just hits the nail on the head. This whole thing isn't just about running code. It's about having the intuition to ask the right questions and then having the creativity to figure out how to get your data to answer them. Which leaves us with one final, pretty interesting question to chew on. When we're talking about building these truly intelligent systems, is the most valuable skill that rigorous, step-by-step application of science? Or is it the intuitive touch of an artist who just knows how to sculpt raw material into a masterpiece? Definitely something to think about.